Welcome back to my implicit differentiation series. This episode I'm going to be talking about, this is going to be the first of about 4 episodes where I will use implicit differentiation techniques to find the equation for the tangent line on certain graphs at certain points. Okay, so let's get started. Today we'll be focusing on one called the cardioid. I'm a terrible drawer, but it basically goes something like this. Looks a bit like a heart, hence cardioid. And the point we're looking for is 0 for x and half for y, which is there. Okay. This example is taken straight out of the book that I work with, James Stewart Calculus, Percentage Learning. My camera can't focus. Anyway, that's the example right here. We find the tangent line at that point. Okay. So, let's begin. So first we have our equation that when you type this in you get that, and it looks something like okay. And what we're going to do now is derive both sides. I'm just going to use quotation marks to signify directly above, because rewriting it would be a pain. Okay, so let's get straight on to finding the derivative. This side, it's just 2x, and then multiplied by the derivative of x, which is the inside. Same with this one, plus 2y multiplied by the derivative of whatever's inside, which is just the derivative of y with respect to x, equals, here we're going to just expand this out, we're going to derive it, so we're going to bring the 2 down, the inside stays the same, take 1 off the power, and then multiply by the derivative of the inside. So the derivative of this inside is 2x squared, 2x squared, the derivative would be 4x, multiplied by the derivative of x with respect to x, plus 4y multiplied by the derivative of y with respect to x, minus x. The derivative of x is 1, so minus 1. Okay, so once you've got to this point, you don't need to do any fancy rearranging, chopping and changing. What we're going to do is we're going to input this value, these values, this for x and this for y. And what we'll get down here is we'll have 2 multiplied by 0 plus 2 multiplied by half dy dx equals, we're going to expand this in, we're going to expand this 2 by expanding into the bracket, so it's going to be 4, and where the x is, it's going to be 0 squared. It's going to be multiplied, 2 multiplied by 2 is 4. We're going to put a half where the y is, square it, minus, it's going to be 2, and x is 0. Okay. Then we're multiplying that by 4x, which is 4 multiplied by 0, plus 4y is a half dy dx, and then we're going to have minus 1, okay, because the minus 1 doesn't change. That here simplifies, this is 0, this is going to be 1 times dy dx equals 0, That's going to be a quarter. Quarter times 4 is 1. So it's going to be 1 for that. Multiplied by whatever's in here, which would be 0. Half of 4 is 2. dy dx. Not better not put the multiply there. And then minus 1. Okay, so here we have dy dx equals 1 times 2 dy dx. 1 times negative 1, that's just negative 1. Okay, so what I'm going to do is bring this over to that side and make it a positive 1. And then I'm going to subtract dy dx on this side, which will make it just dy dx. Therefore, dy dx equals 1. And because that's the slope, you could also say that the slope is m in the straight line equation, because it is. M is rise over run. Rise over run is the slope. Therefore, the derivative is 1, and 1 is m, which is the slope. Anyway, so now we have m. Now we're going to use the equation y. Take y1 equals m, bracket x, take x1, which basically means y minus the y coordinate equals m, bracket x, minus the x coordinate. So that's going to look like y. We input the y coordinate, which is half, equals m. We said m was 1, multiplied by x, minus 0, because the x coordinate is 0. If we expand this out, we get y. I'm going to add this onto the other side. So we're going to have a plus, we're going to add 1 over 2 on this side. And it's going to be 1 times x, or just x. 1 times 0 is just going to be 0. Therefore, the equation will be y equals x plus a half. And that is your equation for the tangent line. Alright, well, thanks for watching this video. I hope this helped, and I hope you have a good day.